For the Ksp lab, you need to gather all of your materials. What I'm not showing you here is the water that I needed to gather. So label your beakers. I'm labeling mine Cabbage and Universal. You would label yours Trial 1 and Trial 2. And you need just a pinch of calcium chloride. You see this amount? It's actually within the error limits of your scale, so there's no use measuring it. So we're just going to put a pinch of calcium chloride in there. And then what I want is the mass of all the liquid that's going in this beaker. So I'm going to start with my Cabbage Indicator, and you see I put in a little more than a milliliter of Cabbage Indicator, and I accidentally splooshed my water a little bit too heavily, but whatever you do, record what you have. And then set up your second trial as well. It's just a time-saving technique, except this time I'm going to use the Universal Indicator in order to show you that one as well. Record the mass of all the liquid that goes in, and then that entry is going to go in total mass of liquid added to calcium chloride prior to titration. And then I'm going to just, for a sanity check, I'm just going to write down the mass of the trial beaker in case the scale turns off. When I was building this lab, my scale turned off more than once and it was frustrating. So a little bit of a sanity check. Then you're going to make your sodium hydroxide. Now you need 0.5 gram of sodium hydroxide. Be sure to write down all of the digits on your digital scale. They are all significant. You see my scale reads, there it went to 0.49. I would take that 0.49. See, sodium hydroxide is hygroscopic and it absorbs water from the air. So then I need the mass of the water that's going in here, and you want somewhere between 40 and 50 milliliters, which means 40 and 50 grams of water. And I'm going to use a dedicated pipette to stir that. And as you can see, I'm trying to keep my lab space clean because I don't want any cross-contamination. I also don't want to make an enormous mess. And then we're going to titrate, and we're going to titrate by mass with this one. So you're going to put your trial beaker on the scale and tare it. Then I'm going to zoom in to show you, because with the Universal Indicator, it's possible this will only take one drop. It depends on how you made your solutions. So I'm going to show you, see how it went from blue to purple? That one drop, that mass, needs to go in titrated mass 1. If you're using the Cabbage Indicator, you're not going to have a titrated mass 1. But now I'm going to keep going. I'm going to keep adding sodium hydroxide until I see some slight turbidity. Slight turbidity means you start seeing something in that liquid that's not quite transparent. And the camera didn't pick it up very well. But what you're looking for, you can tell there's something else there. It almost looks thicker. That's what you're looking for this slight turbidity. And then that mass, once you're convinced that there's some turbidity, that mass gets written down in titrated mass 2, sodium hydroxide added until slight turbidity noted. That's the T2 point. Then for the second trial, we're going to start over by taring the new beaker and then adding my sodium hydroxide. Now again, the Cabbage isn't going to have a T1 point, it's only going to have T2, but you see that transition from purple to blue happens quickly, and then we go from blue to green. But what we're looking for here is more yellow. And you need to watch this, because once you hit green, the difference between green and yellow for me was 2 drops, and the camera didn't actually pick it up real well. But you can you need to watch for the turbidity here as well. So that transition occurs here in just a few drops, and again, the camera didn't quite pick it up, so you're going to have to trust me that there was a little bit of turbidity. And once you see that turbidity, that mass, so the mass of the sodium hydroxide that you've added, goes in titrated mass 2. Again, you're not going to have a titrated mass 1. And then I wanted to show you, after this had sat for a minute or two, you see how yellow this solution looks in comparison. And you can tell that it's not quite transparent. And then the purple one, also you can tell, although it's not quite focused, it's not quite transparent. That's what you're looking for. So now let's look at the data treatment for this lab. So the easiest thing to do is to start with the total volume of liquid. So I'm going to start with the total volume of liquid at T1. And see, I've already inserted this before I realized that it was a calculation. I tried to make it apparent and then I screwed it up. So the yellow cells are cells you need to record. Again, if you have a Cabbage Indicator, you're not going to have a titrated mass 1 or a total volume of 1. You're only going to work with the 2s. So I'm just going to cross out these 1s real quick because we're only going to work with the 2s for the Cabbage Indicator. But for the Universal Indicator, we do have those 1 points, and I would like to show you why. So to find the total volume of liquid, what I'm going to do, or what you should do, is take this mass here, and you're going to treat this mass as if it is a milliliter, because we're going to go with a density is 1.0 grams per milliliter. So this would be 10.90 milliliters because it's 10.90 grams. And add it to this mass of liquid. And when I do that, then I get the total mass of the liquid, 10.94. Then I can calculate at T1. So here I'm going to move to this row here. So the concentration of hydroxide at T1, we're going to take our titrated mass. So our titrated mass, let's just get a whiteboard out here. Our titrated mass 1 was 0.04 grams. So that's how much sodium hydroxide went in order for me to get that color change. But then how did this is sodium hydroxide solution. But how did we make that sodium hydroxide solution? Well, I took 0.49 grams of sodium hydroxide and I made 46.93 grams of sodium hydroxide solution. You see how the grams of sodium hydroxide solution both cancel out. So now I have grams of sodium hydroxide. Well, 1 mole of sodium hydroxide is about 40 grams of sodium hydroxide. So now I've converted into moles, and that's fantastic. I need molarity. So I need to use that total volume here. So that total volume at T1 was 10.94 milliliters. So in liters, it's 0.01094 liters. So when I crunch those numbers, then I get a molarity, and this is the molarity of my sodium hydroxide, of 9.54 times 10 to the negative 4, capital M molar. So I would write that one right here. Now, the universal indicator stops changing color at about a pH of 10. And that's fantastic. But we need a pH of about 12. Actually, the universal indicator, when I tested it, it was closer to 10.5. So we have this multiplicative factor. We need to multiply the concentration by 15 in order to get to the pH we actually need. So you simply take this concentration and multiply it by 15. And when I do that, I end up with a value of 0.0143. And it's going to drop. So 0.0143 is the concentration of my sodium hydroxide at T1. Now the concentration of my calcium, remember with the Ksp, the relationship for the Ksp is that the concentration of the calcium times the concentration of the hydroxide squared, because we make 2 OHs there. So the concentration, because the stoichiometry is like this, the concentration of the calcium is half of that of the hydroxide. So I take this value of hydroxide and I'm simply going to divide it by 2. And when I do that, I get the concentration of the calcium, 0.0071, I think that was a 5, yeah, so that'll be 6, capital M molar. And now to find the Ksp, I take my calcium concentration, which looks like this, and I multiply it by my hydroxide concentration squared, but I have to get it right. So I have a Ksp value at T1. My estimated Ksp value is 1.46 times 10 to the 6th. Again, your values will be different. Then I'm going to calculate my concentration of hydroxide at T2, but I need the total volume of liquid at T2. So I'm going to take that initial mass of liquid, 10.90, and I'm going to add the total volume of sodium hydroxide that was added, 1.02. So my total volume of liquid now is 11.92 grams, or milliliters if we're talking about volume. We measured it in grams. So then to find the concentration of sodium hydroxide, I go through a very similar set of steps. So I'm going to use, this time, 1.02 grams of sodium hydroxide solution, but I'm still going to use that same, those same values. So we have 40 grams of sodium hydroxide for 1 mole. I use the same values that I used before because I used the same sodium hydroxide solution. So this is a 46.93 grams of solution. But now I use the total volume, 0.01192, and that's liters in order to find the molarity of my hydroxide. So the concentration of my sodium hydroxide is 0.0223. So that value goes right here. I forgot my 3. The concentration of the calcium then is half that value, so 0.0117 molar, and then the Ksp. So I square the hydroxide value, I multiply it by the calcium value, and I get 5.55 times 10 to the negative 6th. Then to find the error, just use this equation here. You use your Ksp value here. So for my sample here, it would be 5.5 times 10 to the negative 6 minus the theoretical value, 5.02 times 10 to the negative 6. You take that difference, divide it by 5.02 times 10 to the negative 6, and then multiply it by 100. Now, we are working with very small numbers, so it is expected that you're going to have high error. The point is for you to see how these calculations occur. Now, for the Cabbage indicator, the calculation is very similar. You just don't go through the T1 step. You only do the T2 step.